Find the linear approximation for the function f of x equals x squared plus 1 over 4x plus 2 at a equals negative 1. Then use the result to approximate f of negative 1.012 and f of negative 0.994. The linear approximation involves the function f of x, which is x squared plus 1 over 4x plus 2, as well as its derivative, f prime of x, which will make use of a quotient rule. Derivative of the numerator, 2x, times the denominator left alone, 4x plus 2, minus the numerator left alone, x squared plus 1, times the derivative of the denominator, which is a 4, all over the denominator squared. In the numerator, we're going to distribute the 2x into there, which will give 8x squared plus 4x, as well as the negative 4 into here, which gives a negative 4x squared and minus 4, all over the 4x plus 2 squared. Now we can combine like terms together in the numerator. There's an 8x squared and a negative 4x squared combining to be a positive 4x squared. There's a positive 4x and there's a negative 4 all over 4x plus 2 squared. The next thing to do is evaluate f at the a value of negative 1. So f of negative 1, which will be negative 1 squared plus 1 all over 4 times negative 1 plus 2. Negative 1 squared is 1 plus 1 over 4 times negative 1 is a negative 4 plus 2. 1 plus 1 comes out to a 2, and a negative 4 plus 2 comes out to a negative 2. 2 divided by negative 2 is a negative 1. And then evaluate f prime also at the a value of negative 1, which comes out to 4 times negative 1 squared plus 4 times negative 1 minus 4 all over 4 times negative 1 plus 2 squared. 4 times negative 1 squared is 1. A 4 times a negative 1 is a negative 4, and then minus 4 all over 4 times negative 1 is a negative 4 plus 2 squared. 4 times 1 is a 4, and then minus 4 minus another 4 is a minus 8, all over negative 4 plus 2, which is a negative 2 squared. 4 minus 8 is a negative 4. Negative 2 squared is a positive 4, and negative 4 divided by a positive 4 is a negative 1. The formula for the linear approximation L of x is f of a plus f prime of a times x minus a. For this problem, a is a negative 1, so this becomes f of negative 1 plus f prime of negative 1 times x minus a negative 1, which is f of negative 1 plus f prime of negative 1 times x minus a negative 1, which comes out to x plus 1. We have values for f of negative 1 and f prime of negative 1. They're both negative 1. So those can now be put into place in the linear approximation, giving negative 1 plus a negative 1, which is the same thing as minus 1, times x plus 1. The linear approximation can be simplified by distributing the negative 1 in here, giving negative 1 minus x minus 1. And then the constants can be combined together, giving a negative x minus 2. The next thing to do is to approximate f of negative 1.012. The linearization, or the linear approximation, can be used to approximate f at any values that are near a. And negative 1.012 is near negative 1. So we can use L, the linearization or the linear approximation, to approximate this. The best version to use is the original version. Just numerically, it tends to work out a little bit easier. So this will be negative 1 minus 1 times negative 1.012 plus 1, which gives negative 1. And then minus 1 times negative 1.012 plus 1 is negative 0.012. Times that with a negative 1, it comes out to a positive 0.012. Add that to a negative 1, and it comes out to negative 0.988. To approximate f of negative 0.994, we can use the linearization or linear approximation at negative 0.994. Using the same form above, we'll give negative 1 minus 1 times a negative 0.994 plus 1, which will give negative 1 minus 1 times negative 0.994 plus 1 is positive 0.006. So we have minus 1 and then minus 1 times that, which will give minus 0.006. And minus 1 minus 0.006 comes out to negative 1.006.